What's up guys, my name is Andre and welcome to a new video. Today I want to go more in depth about the parts that I used on my system. And let's just get straight into it. The first component that I'm going to talk about today is the power supply, which is the Corsair RM850. Now, the thing about this power supply is that I know it is over-dimensioned for the entire build. 850 watts for a system with a 3930K and two 970s. This is very, very over-dimensioned for the entire system. I wanted to go more in depth about these parts because now that I've been using these parts for 3 weeks or more, I feel like I am obliged to just release my own thoughts about this entire build and really just talk about it. So I know the power supply is over-dimensioned for the entire build, but talking about the power supply itself, this power supply is just amazing. One thing that normally the other manufacturers of power supplies do, or the other brands, because the brand never manufactures the power supply, they buy Chinese designs and then put their brand onto it. So the thing about these power supplies, or the thing about the other brands, is that they always rate the power supply above what it can actually deliver. So say you grab a cheap but of somewhat good quality 500 watt power supply. The chances are that power supply can actually deliver 500 watts, but once you reach that point where it's delivering 500 watts of power to the computer, the components are just being driven to their absolute limit. You cannot go past 500 watts. Now, the thing about Corsair power supplies that I have seen over the years, because before I got this power supply, I've seen loads and loads of reviews and actually analyzing the entire not the architecture, but the design of the designs, yeah, of the power supplies that they buy, because Corsair is just a brand. The actual company that manufactures this power supply, the 850 watt model, is a company called Chicony, or Chicony if you want. So Corsair has nothing to do with the actual manufacturing of this power supply. Chicony makes the power supply and puts the Corsair brand on it, and this is sold as a Corsair power supply. Now, the first, as I have read, the first revisions of this power supply had a problem. This power supply has a zero fan mode, i.e., the fan will not start up unless you're drawing a certain amount of power from this power supply. The problem on the first revisions was, even if the power supply was overheating pretty much, because there was no airflow inside of the power supply, and normally power supplies are rated to work at their maximum rated capacity at 50 degrees Celsius. This power supply is rated to work at its maximum rated capacity, 850 watts, at 40 Celsius. And some people thought that was a put-off. So even when the power supply was overheating because there was no airflow in it, if you were not drawing at least 400 watts from the power supply, it would not start up the fan. And then because of that, it would just overheat and shut the computer off. So this apparently is the second revision of the RM850, although it's still the first version of the RM850. This is the oldest RM850 that there is on the market. It's not sold anymore. The newer version that you're likely going to see off this power supply is the RM850i. It's an updated model of the same power supply. So, how does this power supply behave? At least with me. So normally, I'm not gaming. Usually, you would think that, because I have two GTX 970s, I would game all day, but that's just not true. Usually, I just waste my time on Facebook. As you can see, it's already open in there. Usually, I just waste my time on Facebook, and that's about it. Sometimes I play Minecraft, which still it's open right now. I just play some Minecraft and do some amnesia deduct descent mapping and modding. And that's about it. I don't play some very heavy games. In fact, I even have SLI disabled in order for some games to work properly, because even though the game doesn't have an SLI profile, sometimes the SLI just makes the game go a little bit crazy. I'll talk about SLI later in this video. I'm just doing, I mean, the computer is just barely sucking any power apart from the CPU, which sucks 100 watts almost all of the time. The power supply is completely fanless right now. If I were to take the camera off of here and aim it down there, if you can see it, as you can see, the power supply is fanless, and that's it. The power supply works without a fan. It's true, the fanless thing is absolutely true. This power supply does actually work without a fan. Now, this power supply is so efficient on its heat generation that the amount of heat that it generates is not enough to overheat the power supply when under 400 watts of load are being drawn from it. So for example, right now I am drawing less than 400 watts of the power supply, and the heat that it's generating working under 400 watts of load is not enough to overheat itself, even when there is no airflow. And I find this to be fantastic of this revision of the power supply. Now, when you do draw over 400 watts of power from this power supply, the fan is not going to start up immediately. What will happen is that there will be, like, I don't know, probably a 20 second delay between you starting up a game that really uses, you know, all the system's capacity, you know, all the CPU and all the graphics cards. And then usually what happens is that the fan will go 100% speed for 15 seconds. So this is a 140 millimeter fan. So even at full speed, it's not loud at all. It's super quiet even when the fan is running at full speed. So the fan will kick to full speed for 15 seconds or something, and then it will just go down to a mode where it's spinning quite slowly, and it's absolutely dead silent. You cannot hear even the fan spinning because even the bearings are so good on the fan. And that's about it. This power supply can reach up to 90 to 92% of efficiency under certain conditions. I think, yeah, when the computer is sucking, yeah, around 430 watts, 450 watts, which is the sweet spot of this power supply, it can be as efficient as 90 to 92%, and that is just fantastic. Because efficiency is one of the greatest problems of power supplies. On power supplies, on switching mode power supplies such as this, we have something called efficiency, which is how much power the power supply is delivering versus how much power it's drawing from the wall. So, on a perfect power supply, if the system is drawing 300 watts of power from the power supply would draw 300 watts of power from the wall and deliver 300 watts of converted power to the computer. But of course, as nothing in our universe is perfect, neither a design made by a human being, the switching mode power supplies will never be 100% efficient. They can be so efficient, very efficient in fact, but they will never be so efficient. So the maximum efficiency at the sweet spot that this power supply will have is 90 to 92%, and I've seen that from actual tests. This is not information that I've read on the box. I have actually built my own switching mode power supply in the past. I know how these things work from top to bottom. This power supply is just amazing. This is the resume of everything that I have to say about this power supply. If you find one of these used, go for it. You will not regret it. I'm giving you my word that if you get one of these power supplies, you're not going to regret it. Trying not to sound like a salesman now. Moving to the graphics cards now. Why did I choose two 970s? Firstly, I chose one 970. When I was searching for graphics cards of this tier, I was kind of hovering around either a 780 Ti or a 970. And then I ended up going for a 970 because even though it was more expensive, probably 30 euro more expensive when I bought the first one, which is the top card right now, it had 1 gigabyte more of RAM, and the TDP of the card was 100 watts less. So a 780 Ti will draw 250 watts of power, and it only has 3 gigabytes of VRAM. Now, some people may say, oh, but that's fine, because the 780 Ti has more CUDA cores, and the memory is communicating with the GPU in a faster way, and blah blah blah. Really, the 100 watts more that it draws in my vision, it's just not worth it. And it's not just power that it's being drawn. All that power is being converted into heat, and it's being blasted off to the room and into the case. So you have to handle with the massive heat output of that card. And this is something that I was not cool, no pun intended, about that graphics card. So I ended up going for a GTX 970, and Levi was able to source the first 970, the top one you're seeing right now, for 145 euro when I first bought it. When we first bought it, because Levi was the guy that basically sourced all the parts that you're seeing in this shot. Yep, my entire computer came from the Netherlands. Levi sourced all the parts. I have already said that before, and I am proud to say that again because he is the guy. So, since I already had a 970, I think I already talked about this briefly on another video when I was talking about the parts, but in less detail. My original plan was to go for an LGA 1366 rig, and in fact I still got the motherboard that I was originally going to use. It's stored under my desk because I'm not using it currently. So excuse for the stupid heatsink on it, but this is the motherboard that I was originally going to use for my system. This is the Asus P60SE. This is an LGA 1366 motherboard that supports the 6-core CPUs. Now, I was originally going to use this motherboard for my system, but then more money came. I was able to sell some other stuff here on my room, because I always have stuff stored in the corners and things that they're a little bit valuable. So I ended up selling more stuff, and apart from donations that I received, and then I was able to get something better. So with this LGA 1366 system, I was also going to build a socket 1155 system with a 2600K. So I would end up with two systems. One with the Xeon X5670, which is a 6-core 12-thread system, and then I would end up with a second system with an i7 2600K. And then I just thought to myself, instead of getting two systems, which the second one I'm pretty much never going to use, why don't we just focus the entire money that we have on building one strong system? And that's pretty much what we did. So we basically, I still got the motherboard from Levi because he was holding this motherboard for me for so long that I thought I'm going to get this motherboard from him, because otherwise, he was selling this motherboard anyway, and I said I was going to buy it, so I bought it. And then we started searching for kits with 4th gen and 3rd gen Core i7s all over the place. And then Levi came across this kit, which came with a Cooler Master Seidon 120V water cooler AIO. It came with the motherboard, the Asus P9X79, and it came with a 3930K. So that kit was 300 euro, so we bought it from the same guy that sold Levi the second GTX 970 under there. So the motherboard, CPU, and water cooler and the second 970 all came from the same guy. All the memory sticks are exactly the same. They're even the same date code, even the same lot, if I'm not mistaken. Those are ECC non-registered DDR3 sticks. I have currently overclocked them to 1866 MHz, basically the maximum speed of the memory controller on the CPU. Although I can overclock the memory controller because, it's X79. And the power supply we sourced from another guy that was 70 euro. Yes, I paid 70 euro for this power supply in Brazil. In Brazil, this power supply is absolutely expensive. You would not believe if I tell you how expensive this power supply is in Brazil. So this power supply in Brazil is around 250 to 260 euro. I bought this power supply for 70 euro used with all the cables. Now, the kit was 1100, yeah, it was 1100 BRL, Brazilian real. The first card was 545, yeah, 545 BRL, and the second card was 500 and, how much did we pay for it? 180? Yeah, I think it was, so we paid around 670 Brazilian real for that. So the system is quite valuable in here. And these prices that we bought the parts for, these prices I would never be able to find at all in Brazil. These prices are like extremely good. Even when I bought the second 970, that was just, I don't know, probably 3 days before the whole mining boom occurred. So I was absolutely lucky to get these two 970s before the mining boom occurred. Because even 970s, people even started, like, every single card imaginable was being used for mining, and all of them were just sold out, even the used ones. So people first bought the 580s, the RX 580s, and then the RX 570s, and then the RX 560s, and then they started moving down the tier. So they bought RX 480s, 470s, 460s. I don't know if anyone was mining with RX 460s. And then they moved to NVIDIA. So they started mining with 1070s, and then 1050 Ti's, and then 1060s. So every single card that had a decent performance for gaming was being used for mining. And then when even those cards were pretty much out of the market, people started buying GTX 970s. This was later in the mining boom. I think probably a week before the Bitcoin or the Ethereum value started to drop drastically. So I'm not mining anymore with these cards because I found that I could not extract the money from my minings. I mined probably 50 euro, and I was not able to recover any of it. The first time I was using an external wallet, so I mined 25 euro on NiceHash, and then I sent it to an external account. The fees were so high that from the 25 euro that I mined, I probably received only, I don't know, 70 euro. Everything else went to fees. Okay, then I said, oh, I'm gonna create a NiceHash wallet then, because then I can receive the earnings daily instead of every 2 weeks or something. And so it was. I mined 20 euro, and then I went to this website where you can sell Bitcoins. Tried to sell my Bitcoins, but NiceHash is so slow to transfer the Bitcoins that the website that sells Bitcoins canceled my selling process, my selling thing, whatever, because NiceHash didn't release the Bitcoins in time. So I cannot practically take out, withdraw my Bitcoins that I mined, and the fees are way too high. So I just said, screw it, I'm not going to be mining anymore, especially because I'm mining a quarter of what I was when I started mining. It's just not practical anymore. And it's not because of energy. I have free energy. I literally started stealing energy just for mining, and then the market does that with me. So I don't know if you can see that, but see that wire over there? Yep, that's a wire that goes all the way to the energy pole out there, out of my house. So I'm stealing power to run my systems now. And the original intent was really to mine, so that I could mine as much as I wanted without increasing the power bill. And then the market started falling apart. Even mining, I was not mining Ethereum because it was just impractical. The drivers for the 970 were broken and were mining completely shit on Ethereum. Normally, a 970 will do 20 kilohash on Ethereum. I was doing 3 kilohash with 2 cards. This is how broken the driver was. And I didn't feel like moving to an older driver just for mining. So I said, screw it, I'm going to mine using Equihash. Equihash, I'm not sure what, okay, so I was mining Zcash, there we go. So using Equihash, I mined around 25 euro worth of Zcash using Equihash, which was the fastest algorithm that would run on two 970s. And that's it. I was not able to extract my money, and, well, there you go. I'm not mining anymore, so in case people were so furious at me that I bought two 970s to use for mining, I'm not using them for mining anymore. I stopped mining completely. Gaming. How do these two cards fare in gaming, and what about SLI performance? Man, it's amazing. A single 970 is still extremely capable. It's unbelievable. A single 970 will already handle something like Battlefield 4 at Ultra 1080p. A single 970. And then once you put in a second 970, you're looking at perfectly doable 4K 60 Ultra Battlefield 4. And I actually proved that on a video that I released, where I made a gameplay, of me playing Battlefield 4 at Ultra settings 4K, given, the game was running with VSync enabled, but with VSync disabled, the game was right over 70 to 80 FPS. So as you can see, two 970s have a lot of power. The only game that I ran across memory limitations, or VRAM limitations, was Resident Evil 7. So I'm gonna add the first sub-subject on this section right now, which is, what about the 3.5 gigabyte VRAM problem on the 970? Okay, so apparently this was fixed in later revisions of the 970 because on Resident Evil 7, which I might even open right now just to show you that it's true, on Resident Evil 7, RE7 is a console game that was ported to PC. And the port was actually quite badly made. So let me just increase the pump speed because I've got a makeshift controller on the pump, otherwise the pump is just annoyingly loud. So I'm opening up RE7 right now just to show you, so it's going to be loaded in a couple seconds. So SLI is currently disabled for compatibility reasons with other stuff, because I'll get to SLI in a second. As I said, it seems like the 3.5 gigabyte VRAM problem was solved because RE7 is a console game that was ported to PC, and it has memory holes, or memory leaks, so to speak. So the game will use basically as much memory as it can on a given scenario, and it will just cause massive stutter. Not massive stutter, but very annoying spaced stutters that I hate, and well, that's it. So RE7 is one of those games, or in fact the only game, that actually makes use of pretty much all the RAM that I have in this computer. So I'll just refocus the camera in there. So yeah, you can actually read the memory counter up there going up right now. I'll just turn down the damn thing. So this is inside. I want to see if I can get outside. I don't know if I have completed this already. Oh yeah, I have to load it. Okay, let's end it. Load. Guest house, yard. Okay. So you'll see the memory usage going up now. Beware that this is not 1080p, this is 1680 by 1050. It's that odd high-end 16 by 10 resolution that people used to use back in 2009 or 2010 when GTX 570s were a thing. And you can see the memory usage going up immediately, and this is not even 1080p. Yes, I do have VSync enabled, so there is a frame buffer usage increase in there. So we're at 3.2, 3.3, 3.4, so it's going to start going up. If I go out here, you can see, whoa, wait, where's the massive stutter people were complaining about, or the massive loss in performance? Look how much frame buffer we're using on RE7. This is with the game running on ultra settings. And as you can see, off of the 4096 megabytes of frame buffer we have, we're using 4060 or something. And there's no massive stutter, there's no massive performance decrease because it's slow RAM. It's just using RAM normally. Given there are stutters in the game now because of the let me just shut off the lights. There are stutters in the game now because of the memory leaks, but it's still fine. The game plays fine using more than 3.5 gigabytes of RAM. So this is one myth debunked, as you can see. We're currently using over that, and you can see you won't be able to see the stutters because I'm recording on my phone, not actually in the game. But yeah, there's nothing more than just a memory leak and no massive performance drop by going over the 3.5 gigabyte limitation under quotes. And that's about it. There's nothing else to this. So, these cards are just amazing. I love these cards so much. One thing that I do hate, or two things that I do hate about these cards, but not about the cards themselves, is 1, drivers, and 2, SLI compatibility. So I read a lot about SLI and compatibility before getting the second card, or well, the second card was being shipped. And I really saw that, well, it's a finicky thing to have SLI, and the performance is not up there all the time. And it's completely true. Almost everything you read on the web about SLI is true. SLI is finicky to work with. It will require a lot of tweaking most of the time, and sometimes the gains are not that much. And that's about it. The second thing is that the drivers, the latest drivers that I was using, they were unstable. The cards were unstable at stock speed. Because this is a superclocked edition, so you can see the clock speed right there. It's 1380. The card that is actually rendering the game is running at 1380 now. So the cards were unstable on their stock speeds. They're not anymore. It seems to have fixed itself once I reinstalled the driver, because not even SLI was working properly anymore, and I couldn't see the GPU usage of the first card, the top card. And well, it fixed itself. So these cards are amazing. If you want to still get one, please do. If you find them for a good price, because I haven't searched on GPU pricing after the market started to crash, so you might be able to grab a GTX 970 already for quite a good price. If you do find one for a good price and you're moving out of a 960 or a 750 Ti, please do. It's a super nice card, and it might be more expensive than a 1050 Ti or a 1030 new, but this card is just amazing. Yes, a 1070 would be better, but a 1070 is just the price jump is like 970, 1070 goes out of the roof. So grab yourself a 970 for moving off of a slower card, an older card. Please do. It's a must if you're wanting to upgrade your system. Do not go for a 1050 Ti or a 1030 if you're moving out of an even slower card. Go for a 970 if you have the power supply to hold it. Go for a 970. My cards, they're both from EVGA, they're exactly the same revision. Both of them use 2 6-pin power connectors each. So, in case your power supply has a 6-pin power connector, all you have to do is just grab an adapter, and you can run the card just fine. It's yes, there is a risk that you will blow your 12-volt lane on your power supply. By blow I mean suck more power than it's actually rated for, because these cards are actually quite hungry by themselves. But still, it's a nice card, pretty much. SLI, yes, it's finicky, it's buggy, sometimes the performance will not be up there, but if you find games that do use SLI as it's meant for, some games that I could mention would be Crysis 2, Far Cry 3, Far Cry 4. These games have an awesome scaling on SLI, and it is noticeable, especially on Far Cry 3. People were saying, oh, two 970s are not able to handle Far Cry 3 at 4K Ultra. Yes, they are, and once I get my first 1080p panel, I am on the verge of making a video about this, because I have a 1080p display on the mail currently, and I should receive it next week because I'm recording this on Sunday. It's yeah, you can see what time it is for me now. On Sunday, PM, 22:43, because we do use military time in Brazil. It's just more practical than normal 12-hour time as the US uses it. And yeah, so once I get my 1080p panel, you are going to see quite an increase on the amount of gameplays that I'll be doing on the week, and especially you'll be seeing more tests at 4K to see what two 970s and a 3930K can do at 4K. Well, if you like 4K 30 FPS, if you don't mind playing some games at 30 FPS, a game that will run at 4K 30 is RE7. You can actually make yourself your own SLI preset for RE7, and the game will actually use both cards. The performance will be actually increased. It's a nice thing about it, and you can run the game at higher resolutions, no problem. So, yeah, some games will run at 4K 60, some games will run at 4K 30, because these cards are actually quite powerful. And if you have a game that does make use properly of SLI, does make use properly of both cards, you're going to be amazed by the performance of that these cards can still deliver. Now, why did I go with two 970s? Apart from the reason that I was searching for 780 Ti's and ended up getting a 970 because it was more efficient and used less power and, had a 1 GB more VRAM. Because I was already planning, because originally, not only what was I planning to go with a 1366 build, I was planning to, on the future, getting a second 970. So when the donations came from one of my pieces, I received donations, quite a bunch of dollars in donations. I just grabbed immediately a second 970 because I could, and because people were telling me, dude, you should get a 1070. Well, a 1070 is 50% faster than a 970. That's quite an increase by itself. But be mindful that if you have a game that has perfect SLI scaling or almost perfect SLI scaling, two 970s, although not as efficient as one 1070, they will be faster than a 1070 if you have a game that uses SLI properly. Even though these cards have only half of the VRAM that a 1070 has. Now, the 3930K. I'm still even not done talking about these things. Now, about the 3930K. The CPU is a 6-core 12-thread chip with a base clock of 3.2 and a boost clock of 3.8. Currently, I set the boost clock to 4 GHz, so it is very possible that the CPU is running at 4 GHz now. I might even check that out. I don't think you'll be able to read that. I'll just try to show you. There you go. So as you can see, the CPU is running at 4 GHz. So I have a 200 MHz overclock on the boost value. So the CPU is running from 3.8 max now. It's running at 4 GHz. And so far, the maximum that I was able to overclock this chip was 4.9. And this actually is inside what people call the wall of the 3930K. So these chips have a wall at around 4.9 GHz. Few people were able to reach over 4.9 GHz normally. For that, they either had to disable some of the cores, or they had to only run one core and do a massive overvoltage on the CPU. Pushing more voltage through a CPU will not only generate more heat, but also it will make the chip die faster, i.e. it will reduce the lifespan of the chip, and will generate a lot more heat, if I haven't said that already, because my ideas are kind of foggy today. Now, how on earth was I able to reach 4.9 GHz on a 3930K with a Cooler Master C-120V is the reservoir of the radiator was dumped into ice water. That was the only way that I was able to reach 4.9 GHz with this chip, with a core voltage of almost 1.5. Yeah, the V-core voltage was almost 1.5. So I think it was 1.45 or 1.47 that I was running on the V-core. So the chip, so the radiator was sitting like this on a pot imagine like under here we have like almost like up here full of ice water. So the ice water was even moving through some of the fins, but it was not hitting the fan, because if it hit the fan, it would just spread ice water and water all over the place and possibly burn something. And even then, with the radiator dumped in ice water, as soon as I hit benchmark on Cinebench, the CPU jumped to 85, 86, 87, and then the test stopped. So even then, it was not a safe temperature. It was not stable thermally, but it was stable, so to speak. It booted into Windows. I could run the test. It didn't crash on me. If I tried 5 GHz, I would get a watchdog timer timeout blue screen on the Windows startup. Well, that's about it. The the Cooler Master Sadon 120V is a sort of a nice water cooler AIO. The only thing that I do not like about this AIO is the pump. The pump is just way too loud for normal use. Plus, the pump is a 3-pin connector only. As you can see, let me just lock the exposure and focus. So as you can see right there, I've got these wires coming off of this motherboard and come to this black thing over there. That is a makeshift speed regulator for fans, and the pump is connected to it. So when I'm not using the computer, taxing too much out of the CPU, I'll just crank the pump all the way down so I can have some silence, because the pump is really annoying. Sometimes I'm trying to sleep, I have to either shut off my computer or plug that thing in and speed down the pump because it's just way too loud. It won't even let me sleep. Now, one thing that I will be going for in the future, apart from a case next month, yes, I'm buying a new case because you can see this is not proper. I'm having the radiator sitting on a roll of duct tape. So yeah, next month I'm going for a better case, and then later, the system is just absolutely perfect right now. And later, I'm going for probably a Corsair H120i. I cannot remember which one has two 120mm fans. I think it's probably the H120i. I guess that the H series from Corsair is going to have a quieter fan because Cooler Master just didn't do a good job at all. And about cooling performance, with the chip running at 4 gigahertz as it is right now, it does hit its 70s rarely, and basically that's it. Even though I think the main culprit of why my system right here is getting a little bit hot is getting a little bit hot yet, it's because of the 1500 RPM Be Quiet fan that I have in here. It's a Be Quiet fan. I should probably buy a second 120mm fan to put on the back of the radiator. And that's pretty much it. I would not recommend getting a Sadon 120V. I would recommend for you going for a Cooler Master Hyper 212. Between the 120V and the Hyper 212, they have about the same cooling performance, but I can guarantee you that the Hyper 212 is going to be quieter because there isn't a fucking pump running at 100% all the time, because the pump header is 3-pin, not 4-pin, so you cannot control the speed of the fan unless the motherboard supports changing the voltage to control the fan, not just the PWM pin or the 4th pin on the fans. This is what the 4th pin is for, controlling the speed of the fan through pulse width modulation. And that's about it. Last thing I had to tell you is that apparently a common thing on P9 X79 boards is for the sound chip to die. And this is exactly what happened with my board. Yep. I've got no onboard sound anymore because the sound chip toasted up. This is something that I'll have to take a look at, and I'll probably have to buy a sound chip from, I don't know, AliExpress to change the chip myself because it just toasted up. It's a common fault, especially when you overclock it too hard, when you overclock the system too hard, and that's exactly what happened. Like, when I overclocked my CPU to 4.9 gigahertz, I think the stress on the board was so high that the sound chip died. So how am I getting sound? Well, I've got this PAL on my desk now, and even though the sound quality is not close to the onboard sound that I had before, the thing is, this is just so much more convenient. I can just mute the speakers if I want to. And I can adjust the system volume. This is actual Windows volume right here. So, say, I don't know, I'm going to watch some porn. I just click the speaker mute button, and there you go. It's muted. And it actually mutes on Windows. So if I Alt-Tab out of Windows here, I'm going to try to show you what happens. So if I press the mute button, it mutes onto Windows, as you can see over there. And if I adjust the volume, it adjusts the volume onto Windows. This is the best part. No software required. All you have to do is this. Bought this new, plug into USB, boom, it's working in like 2 seconds because Windows has a pretty pretty good driver detection scheme now. And that's about it. I recorded 45 minutes of raw footage. Now I have to edit this and possibly make this into, I don't know, a 38-minute video, because I made a lot of full stops because of cars and motorcycles passing by. But this is it. I love the system so much. I couldn't be happier with the performance. The only thing I am not liking, not about the system, but about how I did it, is the fucking ugly ass case that I'm using to hold it. It's like having a Ferrari on a Volkswagen Beetle chassis, pretty much. So that's it for this video, guys. I don't know if anyone will even watch the video till this far. So if you did, please leave a like and comment bananas on the comments if you watched this far. And I'll see you guys in the next one. Thank you guys so much for watching this video.